GM and WAGME fellow kids, decentralized Solidity femboy engineers will now be looking through a cutting edge protocol, which is going to totally moon and WAGME all of us. In other words, it's Solidity Fridays, and we're looking at Ave Lens.
Let's go. GM, fellow femboy William.
All right. So we decided we were going to look at Ave Lens. Stani from Ave already said a while ago that Ave was looking into kind of a social network. There's been talk of like decentralized Twitter for ages and ages. There used to be even an app, which I'm assuming still exists because the contract's going to be there forever, named Peepeth, which was like trying to be a decentralized Twitter. There have been a few attempts at it, and Stowney said that Ave had an idea for a protocol that they were interested in building out. This very week, amongst all of the other absolute insanity that happened in crypto this week, we actually got our first look at Ave Lens. Ben and I are jumping into this, really without any context. We've been looking at it for roughly the last 2 minutes, which is how we managed to have a couple tabs open on Ben's browser. But if you haven't looked at this at all, then we're pretty much in the same boat as all of you. So this is pro tip. If you go to a GitHub repo, and you hit either the full stop, period, or dot, or whatever you want to call it. So it opens up a web instance of Visual Studio Code. It can be a lot easier to go through code that way. So that's what you're looking at right now. This is the Ave Lens repo. What do you say? Think we should start with the README?
Yeah, okay, yeah, we can do the README. I was also going to pull up the website because I believe there is one.
Yeah, I think there is.
If you guys, sorry, you were so unprepared, and yeah, we were going in blind here.
I'm sure it's open in one of my 190 open tabs right now, but I'm having difficulty nailing it down. Unless I'm just thinking of their Discord server. For sure it's a Discord server.
I do. Oh, there we go. Lens.dev. Lovely.
Okay, there we go. Yeah.
Okay. So here we are. Lens.dev, Lens protocol. So the idea here is, I think everyone's been talking about it, building out a decentralized version of Twitter or decentralized Facebook, basically bringing this big category in tech over the last 20 years, social networking, bringing it to Web3. That's the goal here. And so Lens protocol, built by the lovely and talented people at Aave, they aim to, I guess, build a base layer, an interoperable base layer for this idea of a social network in Web3. And so, okay, so let's go through the TLDR. Lens protocol is a composable and decentralized social graph. So we'll get into what a social graph is now.
Because we don't know either.
Yeah, we've got the Wikipedia up there. Ready for you to build on, so you can focus on creating a great experience, not scaling your users. So the idea is that Lens is where the users live in Web3. It's where the users and the data and their interrelationships live. And you can focus on just building the application layer on top of that and just plug into it. I think, and you're getting something else here, but that's my take.
I'll admit there's kind of two things that I'm interested in keeping my eyes open for. There's something, I'm not sure this is a paradox, but I think it's kind of a issue that a lot of times when we look at a decentralized either messaging or social platform, that things run into, which is that if you take a look at an app like Twitter or Facebook, curation and being able to remove content seem to be really integral parts of the platform. Not just from a moderation perspective, removing potentially harmful content, but also from just a personal convenience, like in terms of you want to be able to see. And when you move into a decentralized architecture, I feel like it gets very hard to remove without opening up doors to privileges and censorship. And I feel like what I've seen protocols like Mastodon or Matrix Element do is basically come up with different running instances so that if you don't like what's going on in instance A, you can just run instance B. And the thing is, though, then what you lose is the massive network effects, and everything kind of stays siloed off. You have some apps like Discord, which I think manage to kind of, if you're just looking at Discord as like a social platform, I think Discord does a decent job somehow hybriding. But even there, in terms of like cross-pollination between servers, it doesn't compare to like a Twitter or Facebook's network effect. And I'm interested in seeing here if this is supposed to be like one social graph, once we figure out what that means, or if like everyone can kind of run their own, like a Mastodon. I guess the other thing I'd be really interested in looking at is like PPEth, when they tried to make kind of a decentralized Twitter, gas prices were still a lot lower than they are now. So actually sending their equivalent of a tweet was a transaction, which would mean that in today's terminology, I'd assume you'd probably be paying upwards of like $70 or $80 to tweet, which obviously is completely unsustainable. Now, I mean, these days we also have other scaling solutions, but even if you're going to put it on something like Optimism or Arbitrum, I would assume that that would mean that you're still paying $1 or $2 to tweet. And I don't think anybody's really interested in doing that. This kind of goes into the whole concept of microtransactions, which are one of the things that I think we originally thought Ethereum and things like that would be good for, but currently we haven't scaled to the degree that something like that is feasible, because having a little itty bitty cost to something like a tweet, like let's say it would be a fraction of a cent to tweet, I would say is actually very favorable because it serves as an anti-bot measure. Because at scale, if you're running bot farms, you end up really having to pay a lot to use them. I mean, email spam is a similar thing. Putting in a little bit of a price there could actually, it could actually help deter spam, but not be painful to actual content. I see in the comments someone saying it's sense to tweet on Polygon. It can be, but I mean, the question with any infrastructure that is giving you cheap transactions and fast blocks is sustainability, like how much the infrastructure can hold up for that. It also, I mean, especially since Polygon has implemented EIP 1559, we have definitely seen the gas prices on Polygon going up also. And remember that the cost to tweet isn't just the price of gas raw, it's the price of gas times all of the gas that you're spending in the transaction. So especially if you're writing the tweet to the chain, which wouldn't be advisable these days, almost certainly that it would be just a link to like an IPFS hash or something like that. Though that means that you also have to worry about kind of pinning or not giving a liveness guarantee to the tweet. Then the price can actually go up more significantly. And I mean, I wonder where the barrier kind of is. Like if you had to pay 10 cents to tweet, how much would you tweet? Like if you're banging out 6 to 10 tweets replies a day, so that's already almost $1 a day on Twitter. Would people do it? I don't know. Maybe, could be. And it would be interesting to kind of see where the line is. But I'd say that's two things I'm really interested in digging into over here, and that was quite a rant.
Yeah, I mean, I'm definitely interested in that stuff as well. As you say, we need to find this balance between filtering out the complete spam stuff, and I think that it's healthy to have that sort of very low cost. That it's not really going to deter anyone adding actual value. But how do you balance that in these blockchain spaces and in the Solidity when gas prices are pretty volatile, especially on mainnet? That's like completely non-viable if you're writing anything to the chain.
Even if you're not really writing much to the chain, like even if it would be very, very minimal, like mainnet's not going to be viable.
Yeah, exactly. So it's going to be interesting to see how they do that. Should we jump into what a social graph is? I don't know if we've covered that yet.
I think it's worth a look.
All right. Well, let's just keep going. Is there anything else here? Soak up the sun. Wow. Okay, so you can let your users shine. That's fantastic. We can maybe get into the dev garden after this, but let's go check out what a social graph is. So here we are, William. The social graph
that represents social. Yeah, you go for it. Sorry, didn't mean to cut off there.
Oh, okay, sure. The social graph is a graph that represents social relations between entities. In short, it is a model or representation of a social network where the word graph has been taken from graph theory. The social graph has been referred to as the global mapping of everybody and how they're related. Okay, so it's basically, it's a map of entities and how they relate to each other. So if you think of Facebook, a person is an entity, a user is an entity, and you relate to other people as friends, or you might follow pages, or you might be part of groups. And so you have these concepts of different types of entities and different relationships between those different entities. Anything else you want to get into here, William?
No, I think that's actually really good. I think that's a really good explanation.
Right. And so here's some visuals of kind of what's going on in a social graph. So yeah, it ends up looking like this when you visualize it. So let's just keep that in mind, I suppose, going into
Someone needs to update this page, though. It's mentioning this thing called Facebook. What's that? A thing of the past.
Hey.
Founders of Meta, don't they know? Don't they know? Okay, yeah. Getting these very regen finance vibes from the branding over here. Like, it reminds me a lot of kind of like some of Iwaki's stuff around regenerative finance.
And I see here, so it is on Polygon. I don't know if did we touch on that?
We did not touch on that. We touched on the comment before that things are cheaper on Polygon than they are on mainnet. I mean, it's definitely one of the, like, it would seem clear they're going in the direction to have low cost. I'd assume Aave has a relationship with Polygon. I mean, they're deployed there.
Yeah, they are deployed there. Yeah, I see Campbell in the chat saying sends the tweet on Polygon. So yes, that's looks like that's what they're going with here. They're deployed on Polygon. I wonder why Polygon over some of the other L1s, but that would be
a business relationship. Wouldn't shock me.
Yeah, interesting. Okay, cool. Where do you want to go from here, William? Do you want to go to the developer garden or to the GitHub?
I kind of feel like the GitHub, but if you wanted to do dev docs first, we could take a look at that.
No, let's just jump in here. Sweet.
ASCII art, yeah.
More of it. Following on from our last Solidity Friday, where we took a look at Zora v3, some beautiful ASCII
not quite
art
as
there.
Cool. Yeah.
Yeah.
Not quite as cool as Zora's user graphs. Yeah. Okay, so it's a decentralized, non-custodial social graph. The phrase "non-custodial" in this like context actually, the phrase "non-custodial" in this syntax actually strikes me as a bit of a non sequitur. Oh, maybe not. I guess what they're saying is that the front end won't hold the keys. Like, I mean, usually non-custodial. Let's start from the other end. Usually, what custodial data means.
Maybe it's data instead of money.
Oh, yeah, that's a good call. Yeah, I think you're right. Not a non sequitur. I take that back. I'm used to it meaning keys.
Yeah. So yeah, so it looks like you still own your, we're guessing, data, and I mean, traditionally in the world of blockchain, when they say non-custodial, they mean you hold your money or your keys to your wallet, which holds your money. So you're in control of your money at all times, versus handing that control over to a centralized exchange, which is then taking custody of your money. And so here, I guess we're going for the same thing, but you hold your control of your data instead of handing it over to something like Facebook, which stores it in their servers and kind of has custody over it.
Mm-hmm.
All right.
So, interesting. So you need a .env with certain private, like it's secrets and certain secrets there. The mnemonic, it says, is optional. So that's interesting. Like, either you can pass in a mnemonic that like private keys are derived from, or something else. Be interesting to see what the something else is. It's also interesting that they require an Etherscan API key. And on top of that, either Alchemy or Infura are supported. I mean, big fan. I do like Alchemy and Infura. I'm definitely not coming to like push down on them. It would be interesting to see them also allow like a pocket network key or something like that. Just try and get more decentralized node infrastructure up here. But yeah, okay, so they're using a Docker environment. Oh, just a note. If they're using Docker Compose and I see a sudo here, there is a very decent chance this does not work on Windows. Docker Compose I think one of the reasons why Docker Compose is there is it makes it easier to spin up a Docker environment, but they need to be written slightly differently for Windows and Unix kernels, at least the last time I checked, which was a while ago. So it could be that those issues have been solved. But if you are on Windows and having issues with this, I would say look into running Windows Subsystem for Linux, WSL, because I don't think this is going to work on like vanilla Windows. Cool. So you also need Node. I guess we could hop in the package JSON, I guess, but let's look at the protocol overview first, I think. Lens protocol transfers ownership of social graphs to the participants that graph themselves. This is achieved by creating direct links between profiles and followers, allowing fine-grained control of additional logic, including monetization, to be executed during those interactions on a profile-by-profile basis. So right now it sounds like, before you mentioned with Facebook, and I thought this was a really interesting point, that you can have relationships between users, but you could also have other data points like pages or things like that. Over here, it sounds like we're really only starting with one primitive, which is the user. And you can actually be the user themselves, the profile, or you can be followers to other users who are being followed by that profile, but I'm not entirely certain of that. And all of those will be a profile struct. So what do we have? We have a pub count, number of publications. Okay, there is some kind of other data point called a publication then. Follow NFT, the address of the follow NFT associated with this profile can be empty. So it sounds like there's some kind of NFT that can be associated with your profile. Fine. Follow module, the address of the current follow module in use by this profile can be empty. The profile's associated handle, which it sounds like is actually being stored on chain as opposed to like an IPFS link. It's interesting. Wonder what I think about that. Strings are unbounded, as in it's a variable length array. Tend to be big gas guzzlers, whereas an IPFS hash is bytes 32.
Well, you could probably just put in the contract some sort of limits on the string.
Right, but I'm saying in general, even when you with the if I remember right, though this is like part of the gas optimization, I need to get a bit more into myself. Just the very fact that it's a string, even when the strings are small, tend to be big guzzlers, and I would imagine guzzle more than a bytes 32 fix. Yeah, so that's interesting. And a string for the URI to be displayed for the profile NFT. So keeping that as a string, I understand, because the ERC 721 and 1155 standards both have the URIs as strings. So in order to keep consistent with the standards, I definitely understand keeping that one as a string. Okay, profiles of a specific URI. Yeah, go for it.
So there's, I'm just going to point out there's a few interesting things here. So pub count, obviously, oh gosh, what happened? No.
Oh, you went into the source. Yeah.
So pub count, that's interesting, sort of like foreshadowing that we've got this publication thing. So as you were saying, so it looks like we've got a few entities here already. We've got someone's profile. We've got this idea of like a follower relationship, and we can get into that with this follow NFT, which sounds very interesting, and a follow module. And then we've got a publication, which is sort of another entity, which is some sort of data that you've posted that a user would create, I suppose, some media or some data. All right. Will, do you want to get into this? Do we want to do publications first?
I think so.
Okay.
Okay, let's take a look at this. Profiles specific URI we saw. Okay, profile owners can publish to any profile they own. There are 3 publication types: post, comment, and mirror. I hope that's mirrors and mirror.xyz, but I guess we'll see. Oh, it probably isn't, though. It's probably like retweeting. A publication is probably like a tweet. Yeah, just looking at those types, I'm almost sure that's what that is.
Yeah.
So like post is when, like, I mean, if you're looking at your Twitter profile, for instance, you have tweets and retweets, and you have tweets, which also includes retweets. Then you have tweets and replies. So it sounds like here, mirrors or retweets are differentiated from posts. They probably are under the hood in Twitter also, even though they also show up in your feed as like something that you tweeted. Profile owners can also set and initialize the follow module associated with their profile. Okay, I'm assuming that has to do something with the publication struct. It's like the one thing that comes to mind easily is that on Twitter you can lock your account so that only people you've approved to follow you or already followed you when you lock the account cannot see your tweets. So like thinking of that as a follow module, it's easiest for me if I just kind of think of parallels to Twitter. I'm assuming like, you know, or imagine if Racer would let you pay to see their tweets, kind of a thing. Publications are on-chain content created and published via profiles. Profile owners can create, publish 3 publication types outlined below. They are represented by a publication struct. So what do we have here? Profile ID pointed. The profile token ID this publication points to for mirrors and comments. So that, like, I'm assuming that's me. In other words, like if I make a tweet, so then the UNT256 will point to my profile ID. It's interesting. The profile IDs, I guess we're seeing from here are actually UNT256s. Assuming that that's just a counter that starts at 0 and goes up, it is kind of interesting. I guess that means that like you've got a little bit of a flex built in about how early you are to lens. You know, assuming Stani gives himself 0 or 1 or something like that. Like, you know, imagine flexing that like you have an ID from the first 100 or something like that.
That's a good point.
It is kind of interesting to me that they aren't using something a bit more random in UUID, like not necessarily an actual UUID, though there are actually modules for doing that on chain. But yeah, interesting. Pub ID pointed, the publication ID this publication points to for mirrors and comments. So basically, if you think about a Twitter thread as a parent with children, so that would be this. I'm assuming this can easily stay 0 for something that isn't a mirror or a comment. Content URI. So here we have a URI string for content, which again is a string and not a bytes 32, which is still an interesting choice to me. Also, addresses are bytes 32s, aren't they? 32, 64, 64, so 128. Yeah, I guess there wasn't really any way to struct pack over here. I was wondering if you made that a bytes. Actually, no, wait a second. That string probably should be at the end, shouldn't it? No, wait, if it's there and it's variable length, I wonder. I don't know. I don't really know how struct packing would work with like a dynamic, like a string. You've got 3 addresses there. Addresses, if I recall correctly, are bytes 32 themselves.
I think they're bytes 20 or so.
But they're their own data type. They don't actually consume 32?
Yeah, I think they consume 20. I think there was a proposal to push them up to 32, so they're a full slot. But
okay.
Yeah, I think you're like basically each of these items is going to take up a slot. There's no packing that can really be done here. Maybe that's like why they don't care about.
Right, but I'm wondering if the string pushes the 3 addresses into a new slot. That's kind of what I'm wondering.
Yeah, the dynamicness of the string in a struct is interesting to look at. If anyone has any resources on that, I'd love to see it.
Yeah, like if it would be after those addresses, especially if the string wouldn't be too large, I'm wondering if it would pack it into one kind of 256. Whereas if it's stuck there in the middle, it'll dump it into another one. I am assuming also that since they're deploying on Polygon, they're not thinking so much about optimizing living daylights out of all of the gas. I kind of feel like I've gotten to the point where I'd rather think about it in the beginning than have to think about it in the middle. Like I'm not a obsessive optimizer, I'd say. I'm happy to leave some things not entirely optimized, especially for the sake of readability. It's been very interesting even just to see with the people that we've had on here in Solidity Friday, kind of the different extremes of like, you know, how much they care about squeezing out a few more gas or just making things super readable. We had Ian Nash from Zora on last week, who I'd say was very much in the readability camp. And we had Transmissions 11, who I think needs no needs no introductions in the gas optimizing camp a while back.
That man will go to the ends of the earth to save 5 gas.
I seem to remember the difference between Soulmate and Open Zeppelin's Reentrancy Guard is actually 2, to be honest. But I could be wrong about that.
Wild.
2 or 3. 3. Maybe it was 3. I think it was 3. Yeah. Okay, so that is the content URI. Now we need 3 addresses. A reference module. I'm assuming that's the follow module that it was talking about. Oh, no, I guess there's different kinds of follow modules. There's reference module and collect module, maybe. I'm guessing collect has a sound like it has to do, like it's monetary. Maybe if the example before you have to pay to read a tweet or something like that. We have the address of the current reference module. So there's reference modules can be empty and a collect module, and that exists for all publications, and a collect NFT. So you can have a collect NFT, or what was the name of the NFT before in the profile? You scroll up a little bit.
The follow NFT? Oh, gosh.
So there's a follow NFT and there's a collect NFT. NFT all the things. Okay. E. So publication types. What do we have here? We have a post. There's a standard publication type akin to a regular post on a traditional social media platform. Posts contain a URI and an uninitialized pointers. Since pointers are only, yeah, okay, so that will stay 0 then. Comment, this is a publication type that points back to another publication, whether it be a post, comment, or mirror, akin to a regular comment on traditional social media. Comments contain a URI. Oh, it's interesting. It does mention that the URI, both in post and in comment, is to a metadata JSON. So, I mean, for people who are familiar with NFT engineering, this is a really common, like there's a well-known concept over there, which is in most cases with NFTs, the image of your NFT or whatever your NFT is probably not on chain. There are exceptions to this. Loot, I think some of Pack's work and others all compile an SVG on chain in the contract. But most of the time they point off chain to a JSON. And that JSON contains various metadata details. If you've ever browsed through NFTs on OpenSea or LooksRare or anywhere else that NFTs are offered, you've probably noticed traits to some NFTs, especially in collections where like you've got like one-on-ones, but they're all kind of similar, or games or things like that. The details of those traits are generally stored in this JSON. And even when you take a look at like loot or rarity or things like that that are packing an SVG on chain, they also pack that into a JSON and return something that can be read as a JSON, even though there's no native JSON implementation in Solidity. It's actually really cool to see how they've done that. I really do recommend taking a look at the loot code. It's pretty funky. Oh, we did corruptions once. We even did corruptions once on this.
Yeah. Good times.
Yeah. So yeah, so these are, so the URIs here are strings that are pointing to, I'm assuming that means there'll be like an IPFS link or something like, or hash or something like that, and they'll point to a metadata JSON. And they have an initial, so comments have an initialized pointer. Mirrors have an empty URI since the content isn't unique, and then have a pointer. So that would make programming wise very easy to tell from the struct if something is a post, comment, or mirror. If it has a URI but a 0 pointer, it's a post. If it has both a URI and a non-zero pointer, so then it's a comment. If it has a 0 URI but a pointer, then it's a mirror. So yeah, I see we have a question in chat. So just to get to that question on my side from a non-Solidity perspective, don't worry, Campbell, you're not a smooth brain. We're all going to make it. Maybe based on confusing an understanding of the term social graph with the graph. Does the Lens protocol look like an actual social network, or does this look like a framework that others will build social networks on top of? So that's a really interesting question. I don't know what Ave's plan is, but let's take a look at something like even Twitter, just going for a traditional social graph here. Twitter in the like bowels of the Twitter data center, or AWS probably. Actually, I wouldn't be surprised if they're running their own, but I don't know. they have databases where they're storing all of the tweets and all of the information and metadata about the tweets. And to some degree, I would say, especially if you're a back-end dev, you would probably call that the actual Twitter. And then you have another team of people who are building a web app on top of that data that can aggregate that data and present it to you in a way that you can easily consume and enjoy, or whatever people do as an alternative to enjoying content on Twitter. Here also, the protocol that we're looking at, and probably all of the code that we're going to look at today, is going to be kind of like that data center layer of what we're looking at. It's going to be kind of the raw data. I don't know if Aave plans on building a front end. I suspect that they do, just from other things that they've done in the past. Like Ryan is already pointing out in the chat, the cool thing about this being decentralized is that you can build your own front end on top of it yourself. Like, let's say Aave builds a front end and they keep on going with that, like, regen, very green, like, vibe, and you just don't like it. You could build your own, like, brutalist, pixelated, neon-bathed cyberpunk front end to it, and maybe since that would be much cooler, everybody would go for that. Not that I'm biased towards pixelated, neon-bathed cyberpunk themes or anything. The truth is, to a limited degree, I do believe you can do this with Twitter. Twitter, as opposed to a lot of the other social networks, is pretty open with their API. So then the big difference would be that Twitter, of course, can shut that down whenever they feel like, or they can filter whatever they give out, or do whatever they feel like to the data. Whereas here, assuming, like, it depends on the code, this is something we really need to see. But being that this is Aave and being that they are really putting front and center, this is decentralized, one would at least hope and expect that that would mean that the Aave themselves have no way of minimizing data. And Float Capital is biased towards pixelated neon front ends, which is one of the many reasons why Float Capital is totally awesome. Fully agreed. Yeah. Okay, profile interaction. So that was the different kind of publications. Now we're going to talk about things that you can do as a profile. You can follow and you can collect. So following is to a profile, I'd imagine. Wallets can follow profiles. It's interesting the user is called a wallet there. Executing modular follow processing logic. Executing modular follow processing logic. Kind of wonder what that means. And that profile selected follow module. And that's what a follow module is. And receiving a follow NFT. Do you have to mint an NFT anytime you follow someone? That would be fascinating. Each profile has a connected unique follow NFT contract, which is first deployed upon successful follow. Follow NFTs are NFTs with integrated voting and delegation capability. Heavy DAO energy. You can vote if Racer should unlock Racer's account or not. The inclusion of voting and delegation right off the bat means that follow NFTs have the built-in capacity to create a spontaneous DAO around any profile. What do you know? I should have just read the next sentence. Furthermore, holding follow NFTs allows followers to collect publications from the profile they are following, except mirrors, which were equivalent to shares and require following the original publishing profile to collect. So I'm guessing collecting is like a read privilege. I'm not entirely understanding here. Collecting works in a modular fashion as well. Every publication requires a collect module to be selected and initialized. Okay. This module, similar to follow modules, can contain any arbitrary logic. Successful collects result in a new unique NFT being minted, essentially a saved copy of the original publication. There's one deployed collect NFT contract per publication, and it's deployed upon the first successful collect. They didn't say that specifically by follows, but I think that that's probably true there too. When a mirror is collected, what happens behind the scenes is that the original mirrored publication is collected, and the mirror publisher profile ID is passed as a referrer. This allows neat functionality where collect modules that incur a fee can, for instance, reward referrals. Note that collected event, which is emitted upon collection, indexes the profile in the publication directly, which in the case of a mirror is different than the actual original publication. Interesting. Okay. So then it's talking about the different modularity. Um, hmm. Hmm. I'm debating just because of time. Like I'm okay. Yeah, I'm
Yeah.
debating just because of time. We should probably just jump into the code. Otherwise, this is going to be a readme reading session.
Yeah. I mean, we're almost done here, but
Readme
like, yes.
Fridays.
All right.
Oh, I didn't
So
realize that was that. But yeah, let's do the code anyway. That's
let's
it.
get it. Let's get it.
Lost interest. Too much reading. No code. So we
Core,
have
I guess.
core
Lens Hub.
interfaces, libraries, miscellaneous, mocks, and upgradability.
Oh Lord, we don't like that.
Upgradability, could it be? Okay.
All right. We've got some stuff in core. It's a good start. Lens Hub, I suppose.
Lens Hub sounds reasonable here. So they're coding in 0.8 incidentally, and they're also using the destructuring kind of curly brace move over here. iLens Hub, events, helpers, data types, errors, publishing logic. We're probably going to need to take a look at the libraries first. I'm just guessing. I have not seen this style for a while, and the one time I saw it before, I actually was very, very grumpy about it. I'm assuming the reason why events and data types and things like that are their own library is so that they can have a specific Solidity file with the events and another specific Solidity file with the structs and all of that. And like, I don't know, like I feel very weird about having separate files for all that. Like, you want to do events and structs and interfaces. I have to admit, like, I haven't really settled on whether I like them more in the interface or more in the contract. I think I'm leaning towards interface. But then to like make separate abstracts for like importing free events and structs, I don't know.
Well, I think, I think the idea is more if you want to share a struct across multiple contracts, like if you're working with that sort of data structure.
That would be the one time that it would kind of make sense. I do agree with that. Like errors, I didn't have the same gripe about. I could see that if the errors are very common across a few different files, that maybe it would be better to do this. But the GigaChat engineers at Aave actually know their craft far, far better than me. So I guess maybe I'll change my mind. Who knows? Maybe in a month I'll be like, all gung ho about doing this. What do you say? I'd say data types probably are the place to start. I'm assuming it should be a fast read also, because I'm assuming it actually heavily reflects the README. But let's see.
All right. So we've got a few things here. It's just enums.
Protocol state. Yeah, we have a full pause, kind of what I'm guessing is like a middle pause, which stops you from publishing, but doesn't stop you from doing other things, and unpaused. We've got a publication type for post, comment, mirror, or non-existent. I'm assuming that's for deletion, but I'm not sure. Deletion should be another kind of interesting thing to keep an eye out for, because you can't really delete from the blockchain or from IPFS. Or you can't purposefully delete from IPFS, I should say. If, like, you can have a node go down and then that node was the only node holding content or something like that. But it's very hard to guarantee deletion. We have an EIP 712 signature. Who is just saying that they really want to see structs used more for signatures? I was just reading someone talking about this. Was it Divar Dump? Might have been Divar Dump. I don't remember who it was. If it was Divar Dump is, of course, the co-author of the best EIP in the entire world, EIP 4494. But what this is canonical signatures are. Oh no, it was Rick Moo from Ethers. Was talking about how he wants to see signatures and structs more, if I recall correctly. So VRS is what's called a canonical signature. It's specified in EIP2, if I recall correctly. When you sign stuff, basically this is what you're doing. There are 3 parts to it, a V, an R, and an S. Those are like cool cryptography things that I don't know how to explain and don't really know. So I'll just say something like, we're not going to get into this now, so I look half intelligent or something like that. But yeah, those are the parts of the signature, and then UN256 deadline. These get used quite a bit in EIP 712, which is a format for making messages that can be signed. Okay, then we have a profile struct, which is the one that we saw in the README, and a publication struct, which we also saw in the README. And then we have a, what's that say? Create profile
data. Do you want me to zoom in a bit?
Yeah, if you don't mind, just a little bit. Yeah, that's great.
So this is probably what you're passing into sort of functions from the front end or whatever, some data, structure, to create profiles, I'm guessing.
Yeah,
And
it's funny
it's
to me that this
interesting.
needs its own struct.
Yeah, it's quite interesting to do this. I've like run into it a few times in contracts where you would have the I guess the profile struct that you're storing on chain, and you need all of this. But when you set it up, you might want some other data to come in, and then you manipulate that data on chain, or you actually can't pass in all of this data from off chain because it needs to be generated on chain, like maybe like a timestamp of when the profile was created. So I think then it becomes quite interesting to split this out and have sort of a purpose-based struct that's just for passing into functions as a parameter from off-chain. Yeah.
Interesting. Huh. It's interesting. You're also passing in the follow module data as raw bytes, compound vibes. Yeah, set follow module with sig data. The at notice should probably explain this. A struct containing the parameters required for the set follow module with sig function. Okay. That speaks to what you were saying also. And it looks like we're going to have a bunch of these. This is really interesting. We're only a little bit of the way through the file. So maybe what we'll do here is we'll just kind of keep a quick eye on what these are for. Like we have a set follow module, which basically puts in some data for a follow module with a signature, a dispatcher, which does the same. And you can see that these all have an EIP 712 sig as a struct also. Then we also have set profile image URI with sig data. Okay.
So I think this is architected,
yeah.
like with all the SIG stuff going on, I think it's quite architected that they really want protocols to build out their backends and their own like sort of social networks on top of this. And it looks like they want the user to do as little as possible, just to like sign stuff. Sign messages and then kind of offload those the gas costs to other protocols or other entities that are going to be transferring things.
Yeah, I was thinking of it even a little bit differently. By delegating everything into signatures as opposed to like traditional sign-in or anything like that, basically you do guarantee that the only thing that someone needs in order to get into their account is a signature, and that you can decentralize without needing something like OAuth or whatnot.
Yeah, that too as well.
Like you're saying, that anyone else can build on top of it. So it's like I do feel it's kind of that like sign in with Ethereum, like we can decentralize signing in kind of vibe also.
Yeah, big sign in with the Ethereum vibes. Nice. Cool.
A struct containing parameters for the post function. So okay, that yeah. Post with sig data. So there's a post and there's a post with signature data. Might be interesting to see when we need which. One's for the post function, one's for a post with sig function. That's great. But it's just kind of like, I wonder what.
It looks like it's the same, except this one has a sig.
Signature. Yeah. I wonder why sometimes you don't need I guess what I'm really wondering is why you wouldn't need the signature to post. Like, otherwise, why can't I just spoof posting from someone else? I mean, maybe it needs message.sender. Maybe post needs message.sender, but post with sig data doesn't. That would also be kind of a bit funky. Struct containing parameters required for comment. Okay. I'm assuming the next one.
I'm thinking here, mirror. Maybe a post could come completely generated on chain, and then there's no way for a contract to sign it to create a signature.
That's an interesting point, actually. Yeah, contracts cannot generate their own canonical signatures, which means that you probably could not have a contract that has an account in Lens. Now, you're saying maybe that's why there's things like post, but we saw a bunch of other things. Maybe you could set up a contract as an account, but they won't be able to update their profile or anything like that because they won't be able to sign.
Yeah.
Interesting. Very interesting point. Yeah. Good call.
All right.
Post sig data. We have comment data. We have comment with sig. So this is also the same dichotomy. We have like comment. We have comment with sig, and I'm assuming then mirror with sig. But I don't know.
Comment with sig, mirror data, mirror with sig, exactly.
Oh yeah.
Got him.
Follow with sig data.
Wait, there's no follow, just without a
But
signature.
there's an overload. Oh, mirror with sig data and follow with sig data. Yeah. So following and collecting both need a signature, and there's no non-signature version. So it's just those three, post, comment, and mirror, that have the non-signature versions.
Interesting. Okay.
Oh, Walt. I actually kind of want to see the errors. You mind diving into the errors?
Sure. Oh wow. There we go.
Library errors cannot initialize error initial. Oh, if something's already initialized, you can't initialize it twice. Fine. Signature expired is for that. Zero spender, they made an error for. That's interesting. We'll be checking zero addresses. Invalid signature, not owner approved, not hub, token does not exist, there'll be certain things that can be called by the governance address. Not governance or emergency admin. There is such a thing as an emergency admin. Color not whitelisted module, collect module not whitelisted, follow module not whitelisted, a lot of not whitelisted stuff, not profile owner, not profile owner dispatcher. I'm guessing a dispatch is some kind of delegation. Publication doesn't exist. Handle taken. That's interesting. Handle length invalid. Like you said, they're actually going to cut down how far that string can go. Handle contains invalid characters. That's interesting. Use UTF-8 in string. Huh. Color not follow NFT. Color not collect NFT. Block number invalid. Array mismatch. Init params invalid. Zero currency. I thought they had one of those before. Oh no. Collect expired. Follow invalid. Model data mismatch. Follow not approved. Mint limit exceeded. And collect not allowed. Multi-state paused and publishing paused. Anything else? No, that's it.
No,
all right.
That's it.
Solidity 8 custom errors. Oh yeah.
We love them. I want to do more of this.
Oh, what about constants? Yeah, I'm getting into it too. I'm finally getting into it. It's the top library.
Yeah. All right. Oh wow.
Suffixes, infix. That's interesting. Is that actually a word, infix?
There we go. Max handle length 31.
31. That probably is the size thing. That's like, yeah.
That would be the
fit it in one word.
Yeah, it's one slot, 31. I wonder why not 32 though. Is there?
I was just wondering that also because I thought 32 was when it actually took that, but I'm assuming there's some encoding byte in front now.
Yeah.
Makes me wonder. I should be checking contracts more because there are error messages that I actually optimized to 32. But yeah. Interesting. Okay. Cool.
Okay.
Let's do the hub.
The hub. Get it. Okay, I'm getting rid of these guys. There we go. Hub.
Whoa, big note. Lens protocol is unique in that front-end operators need to track a potentially overwhelming number of NFT contracts interactions at once. For that reason, we've made two quirky design decisions. Both follow and collect NFTs invoke a lens hub callback on transfer with the sole purpose of emitting an event. Almost every event in the protocol emits the current block timestamp, reducing the need to fetch it manually.
So as Campbell was saying in the chat, I think this is very designed to be sort of like integrated with the graph, the Web3 service of sort of indexing events from contracts. Campbell, you brought that up in the chat as opposed to a social graph. So it looks like kind of both apply here, where we have this callback that specifically just emits an event, so that you have this historic collection on chain of event data of these NFTs being created, which sort of maps to, I think, entity interaction, so like follows, unfollows, posts. So I think that's what's going on here.
The first point I feel like I really don't get all the way, as in it's specifically on transfer. And I'm not really sure I'd understand the point of transferring a follow NFT. Maybe I can, or a collect NFT.
Maybe.
And then it makes sure it emits via the hub.
So I think, like, if you were to just follow someone, I guess what I'm guessing here with the protocol is that it mints the NFT.
Oh, so since it's minting, it does emit transfer. That's right. Mint does emit a transfer.
Yeah. So there's that transfer like immediately that you can index, and then when you
And burn
unfollow
also
it,
does.
it probably
Yeah.
burns it, which is a transfer as well. And that all comes from here. So you really just have to listen to the source of events, and you can
And
get.
so what it does is it just cuts down the overhead on the amount of contracts you need to listen to. Oh, I guess so, because yeah, otherwise there would be a large amount of contracts, and I guess that could get how trying to reason just like off the cuff about how much harder it is to follow a bunch of events on a bunch of contracts from a bunch of events on one contract. I mean, I guess
Well,
it
it's like
allows you to put an extra filter on the query. And I guess I guess what it does is it really saves you one query. As in normally you would have to have a query that would get all of the contract addresses for all of the NFTs, and then you would use that to filter your event query.
but it's probably
And over here you
also
don't need to.
it's probably also like compute and data spend in whatever service you're using, where I think it would scale linearly. The compute you and then sort of the bandwidth data over the internet that you're using would if you're doing it on multiple contracts, it's just like the stream that you're listening to, I suppose, multiplies.
So event queries are actually, I'd have to double check. Event querying from a node directly, I'm not talking about the graph here, is actually really, I think, perhaps the most massive pain point in interacting with on-chain data. The nodes return information very, very inefficiently. There's not a lot of filtering commands and whatnot. When you are querying for event data, you can put in certain filters by topic or by contract. I seem to remember contracts are an array. I'm trying to remember what happens under the hood, though. I think what might actually happen is that the node literally scours everything, but then kind of after it has all of the data returned, cuts it down for you and returns it so that you get like, oh, wait, no, is it that? If you're putting in a filter by contract, it could be it actually does return less and need to look less. I don't remember. I'd have to dig into that again, like the madness that is the JSON RPC sometime. But a lot of the event querying is really amazingly inefficient. Just to be clear, I really don't even mean this as a criticism for client devs or the JSON RPC specification. Ethereum nodes, when you really think about it, have been rigorously optimized to basically be able to work on consumer hardware. There is a huge focus put on making sure they don't balloon in size drastically, like as much as they could. And those priorities, they pay a price elsewhere. And one of the places where they really pay a price is how inefficient that querying one contract for a massive amount of events actually is a significantly less latency than or compute, like you pointed out, than having a long list of contracts for the same. Yeah, cool. So contract lens hub is iLens Hub, lens NFT base.
Before we get into it, well, I want to just point out this is gonna be our worst episode for getting into the actual meat of the Solidity code. We're at like 5 minutes left.
5 minutes left, and we're starting to read the code. Yeah, but we did take a look. I really think there was a lot to learn from the libraries already.
Yeah, I agree.
It gives you an idea of what's going on here. But yeah, okay, let's see what we can like chugga in 5 minutes over here.
We might need to do a second episode of this. Yeah.
Yeah, we might. So we have an internal constant revision. Don't know what that is. A follow NFT implementation, collect NFT implementation. That's immutable. It can't be changed once it's set in the constructor. Modifier only gov, only whitelisted profile creator. This modifier reverts if the caller is not a whitelisted profile creator address. So it sounds like you have to be on a. I'm assuming that there's probably like a beta where you'll have to be whitelisted in order to create a profile. And it's checking that, and probably after a certain amount of time, anybody can, but I don't know. Either that or it's some kind of proof of humanity thing, so I don't get sybiled, but not sure. Constructor sets the immutable follow and collect NFT implementations. Okay. And yeah, want to keep on going?
Sure. Sorry.
Ooh. Apparently we had some stream downtime. Fun. If there was stream downtime, I do think that everything should be recorded separately. So there should be a YouTube upload where, if in case like you really wanted to see that whatever got cut out, I'm assuming it should still be on the regular recording. But maybe I made that up. Guess we'll see. Function initialize. So initialize is something that you'll find in contracts that have a proxy. A lot of times you can't put that stuff in the constructor. You have to set it separately. And then they'll put on a modifier that you can only call it once, which is that initializer modifier right there. Yeah. So we've got name, symbol, and new governance. Name and symbol are heavy NFT vibes, that's for sure. Even though we didn't see, oh, okay. So it did inherit from something called iBase NFT. So I'm assuming I was like kind of debating it. I'm guessing that the hub itself is kind of an NFT. And that since it's a proxy though, so they can't set name and symbol in the constructor like usually would, they're doing it through the initialize function. All right. Set governance, so only governance can set governance. Okay, fine. Oh wait, was there a second initialize function? Did I skip one?
Sorry, I was muted.
No, I lost my mind. Yeah, it was fine.
It's just called
yeah,
super initialize. Maybe that's what you're seeing.
Yeah.
Anyway.
And the new governance address, yeah. Okay, so only governance can set governance. Is initialize locked down? I probably should have checked it. It's referencing a modifier somewhere else, though, I think. I wouldn't worry about it. Never mind.
Yeah.
Gov function, set governance, set emergency admin. We don't know what that emergency admin is, which is a bit worrisome, but, set state.
Wow. Are we React devs here now? Jeez.
Yeah. Major JavaScript vibes. External override if message sender's not. Yeah. Set state, new state. So it's gonna happen weird. I wonder what that is. Whitelist profile creator. So that needs to be gov also. Whitelist follow module also only gov. Whitelist reference module also only gov. So they're not gonna. I'm assuming that prevents someone from making like a really parasitic or malicious module. Yeah, okay. I'd say let's keep on going. What about you?
Yeah. Profile owner functions. This is quite interesting, maybe. So when you own your profile, there's something you can call here. Do you want to go through these ones?
Yeah. So create profile, and this is the first time it could be that there were also some of these up before, but you'll see that it's looking at data types dot creator profile data. So that was that struct that we had before.
So this is interesting, and you're passing that in as call data, so you can very, I guess, efficiently just pass in one variable. You also helps you get around that stack too deep, everyone's favorite Solidity error, stack too deep.
Good call. I hadn't thought of that. That was a good call right there. Yeah. Call data, of course, cannot be altered also, but it's also cheaper to work with than memory. Interesting. I'm wondering also, just like thinking, I wonder what that looks like in JavaScript. Like, do you just pass in a JavaScript object? Do you have to trace on it? Do you have to stringify? Like, what about other languages?
No, you just, I think you just make a JSON object.
JSON?
Pass it in. Mm-hmm. Yeah. That's what I've been doing in tests for this sort of thing.
Oh, you've been using this.
Yeah. Sneakily.
All right. Oh, and they're using this kind of. I still think this is like, I don't know. Every now and then I debate the readability of using this trick. But on 148 UN256 profile ID equals ++ profile counter. Let's say this starts at 0. That means the profile ID is going to be 0, but immediately after 0 is written into UN256, it'll increment it up to 1.
I saw someone was profiling the gas efficiency of doing this versus putting the ++ at the end, and actually this is more efficient.
Oh yeah, it was Eugene. I remember that, the chess guy, the chess NFT guy. Yeah, I didn't read it too carefully though. I know what you're talking about. So we have publishing logic. So this goes to publishing logic to create the profile. So this really is a hub. Like you can tell, these are like really just kind of delegating functions and making a lot of external calls, which is interesting. Set follow module, I'm assuming is going to be a very similar thing. It looks like it's running it through validation first. Interesting that we don't see that by the create. Huh. But for the follow module, there already we've got a validator. Oh, but its validator color is profile owner. Okay. And so that means that the reason why you don't do that in create profiles because he doesn't have one yet. And I am being told that we are at time. How close to the end are we? Nowhere near it, are we?
Gosh, no, not at all.
No, not even close. All right. Excellent. Excellent. Thank you for joining us for Read Me Fridays. I think there's a good chance we'll be doing a second week on this one.
Yeah.
I do actually feel like we gave ourselves like a good start. Like I felt like I came in with context, which is kind of rare. I think that what we will probably do is we will do a second edition of this next week. Stanley actually, if you want some major alpha, originally said that he would try and send a dev over actually to hang out with us and probably be amazed by how incredibly unintelligent we sound on stream. Well, not me, but Ben's like the smart one of us two. But we'll see if maybe they make it for next week. And has been an absolute pleasure, friends. And yeah, more Lens next week, I think. Until next time.